Okay. And what I'm actually going to do right now is I just want to make sure that you guys have access to the files. So just log in to AWS. Let me put you on the whiteboard right now, just for a moment. Okay, just for a moment, hang on. I'm just logging into my console and providing a I have a multi-factor, so I have to kind of get logging into my server and creating a storage content S3 for you guys, and cissp folder or 05 8. Then I'm going to drop some files into that. So let me set properties so that you can actually browse. Oh, I don't think I can actually see if I could get this to work. Properties. You know, I'm creating a folder that you can actually look at. You do have to put in the file in there. Too bad. Okay, so I'm just going to drop one file in there just right now. So I don't have the PDF yet because I'm going to be using the whiteboard, and then I will drop the PDF in there. But I do have a couple things that I created that I saved. So let me just go ahead and put in there. Actions, upload, drag and drop. One. Okay, and I think I should have another one. I have 3 and 4 in there. Okay, so I'm going to upload it. Upload. Okay, so it's uploaded. And alright, so it's done. How about the actions? Properties. Nope, still the same. So I'm going to have to select both. All right, just for kicks, right? Just for testing. I'm going to put permissions. Add permission. Anybody. And save. Open and download. Save. So, and I'm going to just put the link. So that's one link. Please check and make sure that you can actually access it. And what I'll do is I'm going to give you another one. Open. Saved. And so here's another one. These are the ones that, you know, as we remember when we switched the whiteboards. So that's the only one that I saved. You can't get them. Very good. So at the end, before we call it a day, I'm going to make a PDF of the new whiteboard stuff. It's going to be all in one PDF, and I will upload it and give you the same link. So I'll give you the link on the chat. So we'll do that. That'll be the last thing that I'll do. Okay. And good to go. So now let's just go ahead and go back to the presentation material. But for the application security, go ahead and, you know what, because of the time, I want to do something like what we did for the testing. So I'd like to go ahead and give you my presentation, my lecture on it, okay, on the whiteboard. And if we have the time left, then we can go through the presentation material. But you also have the presentation material. They're pretty much covering the book. Okay. So let me just go ahead and go to the whiteboard. All right. When you look at the domains, what you'll find is that a lot of things are repeated. And what I tried to do on the first day was to cover some of the materials that were repeated, but you know, there are a lot more things that are repeated as well. So even though we may not be covering, you know, spending more time on the application security, some of the materials there we've already covered in the other sections. All right. So what I wanted to kind of share with you on the application security and secure development is, one of the concept is that you have to put security at each level of the SDLC. So, you know, software development lifecycle. Every step has something that you can do as far as security is concerned. Okay. So, for example, we already did look at it, right? So, the part about the requirements phase, you have to have the security requirements. On the design, you have to consider the kind of vulnerabilities that you maybe bring in just by the fact that you choose a particular architecture, like cloud, like web services, like centralized. Any of these architecture design will have their own set of vulnerabilities, and those vulnerabilities must be remediated, or measures has to be put into place to remediate that. And every stage you go into the SDLC, you're going to be inputting, you're going to be embedding vulnerabilities just because you do something there, right? You can't avoid it, okay? So every single step, and we saw how some of the things that you have to consider in the development phase as well, the language that you use, because some languages have their own vulnerabilities, well, most languages have their own vulnerabilities that you have to work around. And of course, we talked about how logical flaws get into the application. And also for security, for deployment, because you're moving from the development to the actual operational environment, you know, things change. So the thing that you were assuming in development environment may not also hold true in the deployment environment. So you must make sure that security profile is maintained when you move it to deployment. And the operational phase, we just talked about it, right? All those things you have to do. If you don't do them, you have, you know, put in vulnerability in that step. And the last stage that we didn't talk about is to terminate the system. And when you get rid of the system, you know, you have to worry about what do you do with the data? How do you safely delete data? Especially, take a look at something like in the cloud. You want to get rid of data in the cloud. Well, how do you do that without, you know, leaving any type of remnants that people may be able to have access to after you've got rid of it? Because you're sharing all those hard disks, you know, and the drives and such. So how do you know, right? So all those things count. So SDLC, every single stage has security work to do. Okay? But for the secure development, we're mostly concerned about the development phase. Okay? It's about the code. It's about the language. It's about the database. Okay. So if you're not familiar with it, highly suggest that you actually do go into that, because that is, you know, if you're unfamiliar, I'm sure the concept is going to be pretty unfamiliar to you. It is a section that's quite new, so it's not as big. I'm actually kind of looking at the book right now. It's fairly small. It's probably the same size as the access management, identity and access management. Okay. So I think that's the. Oh no, hang on. No, security in the software development lifecycle is maybe it's a little bit thicker than the access management. Okay. So here are some of the main points when you do application development. And I do have a presentation, so I just want to go straight into it. So let's say, and I'm going to take a web application as an example. I think it's pretty representative. It doesn't have to be web application, but just it's because we are moving towards that direction. So and it's easier for me to kind of explain the concept. So let's say you have a client and you have the server. Okay, and you're connected. There are two major categories of attack. The attack, okay, so the attack is something that attacks the server and the server resources, such as, let's say, a database. Okay, so that's one type of attack. So it's the server-side attack, right? And the other one is it's the client-side attack. So what happens? The bad thing that happens is on the client side, but the fault is on the server. So basically, it bounces off, and the attack happens on the client. Okay, but in both cases, the vulnerability is on the server. And yes, it's true, people do attack clients straight. Yes, they do that, okay? But when we're talking about development, software development, we're talking about mostly about servers and the application that you build on the server or the client software that talks to the server, okay? So at this point, we're not talking about endpoint security per se, but we are talking about the development. So in order to think about what it is that you can do with applications and where can you put the security protection around it, it's helpful to kind of think it in this term. Where is it happening? And you'll see pretty soon why this is the case. Okay? The example that I'm going to be showing you is the server-side attack. I will show you the SQL injection. Okay, and the client-side attack I will show you is cross-site scripting. Mainly because they're pretty demonstrative. That is, it is a representative of these two different types of attack, and it's pretty fun to do. So that's what I'll be showing you. Now, so the first thing, let's take a look at the SQL injection. Okay, so I'm going to show you what an SQL injection looks like, and then we'll explain why that happens. So let me just go ahead and switch over, but I am going to go to that site first, so hang on. Okay, let me just go ahead and switch you right now. So I have a this thing is running on my server. Okay, I have them in the cloud, and after seeing it, if you like to play with it, okay, it's not necessarily a requirement for cissp, but if you like to play with it, I'll be happy to host you on this thing, for free. Okay, and it's called Security Shepherd. So Security Shepherd is a security training. Application security training programs that the OWASP provides, right? So all I have to do is I've just set up a Security Shepherd server on my web account. That's all. So let me go in and show you what that looks like. Okay, so it's like a game. So let me show you. Let me show you the lessons. And SQL injection. Okay. So take, for example, I'm just going to hide the lessons here. Okay. So this one says, please enter the username of the user that you want to look up. Right? So typical, right? Typical stuff. and then you say, hey, let's do terumi on this thing, and say, hey, get this user. It loads and say, oh, no role confirmed for that query. Make sure you escape for whatever, okay? And so then I said, okay, I got to do something different. Okay, so in this case, I'll do this. So if you take a look at, I'll explain why I'm putting in here. So if this is the first time you've ever seen SQL injection, you say, that doesn't even look like a name, right? Yeah, that's the point. So if I were to put that in, what I'll get is I'll get everybody in here, right? So I'll get everything out as a result. And what happened, right? What happened? Because this is an application that's supposed to accept the username and is supposed to, you know, give you information about that username. Okay. So for example, if I were to put, that's right, exactly, Terry. I changed the query. So if I put, let me see if this actually works. Cloud. So that's a username. If I put cloud, would I get that information? Yeah, there you go. You get that information. But if I were to put that word, that thing there, you know, you get that. Okay. So let's take a look at, so this is actually an attack on the server because now you're getting all the information and you're not supposed to get it that way. It's right. It was supposedly it was not planned that way. So let's take a look at the mechanism of how this works. Okay, so here we go. So what we saw was it says, hey, put the user ID. Or username, okay? And then you send it to the application. Application receives it, and it processes that information, and it'll probably query, right? So let me just actually. So you're actually sending that to a server, and the server is talking to a database in the back, okay? And this probably, the database is probably, in this case, it is a relational database because we're doing SQL injection, okay? So once somebody puts in, you know, like terumi in here, okay? So that information goes in. Maybe, you know, ID equals terumi or something, okay? And the application is going to create a query taking that information and send it to the database, and it finds it, it's going to return the answer, and then of course you return the answer this way. Okay, so the typical query would probably look something like this. You have a table that has all that information. Maybe it's, you know, user table. Okay, user table. And the typical query may look something like this. Typical query would be something like select user from table, user table where user equals apostrophe table apostrophe. Yeah, very good. So select maybe like all from user table, right? As you said. Yep. Where ID equals, you know, what I get. So, you know, ID equals ID that I get. And close, right? So if you put terumi in there, it says select all from user table where ID equals terumi. That's basically what happens. But I put in there, right? Right, that's right. So if we were to put that inside where that belongs, let me just go ahead and delete that thing, okay? So let's see. So you can see the actual query. So let me just go ahead and delete that because I wanna expand and so that you can see what happens. So I'm just going to expand it out here someplace. Okay, and you go that or 1 equals 1, and of course I forgot to put the I forgot to put back the end. So yeah, just as what Terry was saying, it now I've actually, so let's take a look at what happened. Now this thing says select all from user table where ID is null, nothing, or 1 equals 1. And 1 equals 1 always evaluates to true. So it's basically where ID is true. Okay, so whatever you have an ID for, you're going to get an output. Okay, so that's the mechanism of the SQL injection, is that you are injecting pieces of the snippet of the SQL statement, and you're changing the actual query, the nature of the query on the fly. Okay, and the scary thing is, if you know what the name of the user table is, in this case, you don't have to know in this case, but let's say you do, right? You can actually do something like this. You can actually do drop table command. And then you could go end and comment. So if you do that, the pieces that are kind of left behind, these pieces, becomes now the comment. So you won't get a syntax error. One of the problems with you're doing an SQL injection is that you get a syntax error and it doesn't process. So you want to make sure that you are able to kind of nullify that. And so something like this will work on MySQL. Depending upon the type of database that you have in the back end, you have to kind of tweak how you put it in. But to protect it is, yeah, as Terry mentioned, remember the first thing that you can do is don't accept anything that has anything other than a name in it, right? So you have to do something called the input validation. Got to do an input validation. Yeah, Terry. Right. So Terry, so now that you mentioned it, right? So that's your strategy for validation. Obviously, looking for special characters, remove them, right? That's right. That's right. You could do that. And so basically, what are you doing? Are you doing whitelisting or blacklisting when you do that? Are you sure? Because you're testing for special characters. Right. But Terry, if you're looking for special characters and spaces and remove them, you're doing a blacklisting, not a whitelisting. Does that make sense? Yeah. Yeah. But it's okay though. I mean, people do that. You know what you just mentioned. We do that all the time. So we don't have to be kind of pigeonholing how we have to actually remediate this thing. Yeah, blacklisting works, but as we discussed before, whitelisting probably is more restrictive. So maybe you're just looking for things that are okay to have, like characters, and just not accepting anything else. So that may be another strategy too. So there you go. So, but the thing is, here's the thing. This is input validation. And another thing that Terry mentioned is the store procedures. So store procedures is where you compile the statement. You compile the statement and you stick it into the database. Okay? And your application calls it. That's all they do. And because the SQL statement is already compiled, you cannot change it on the fly. You can't change it. So if somebody were to put in something like a apostrophe or apostrophe 1 equals whatever, right? It's just going to error out and say, what are you trying to do? It doesn't make sense. And you could do something called the let me see, stored procedures and prepared procedures. So that would be parameterizing your query. So that would be, what you can do as well. None of them are foolproof because people find different ways to stick things in there. But this is basically what happens. Okay? And notice how important it is to do input validation. All right. Any questions on that? Any questions? Okay. So now let's take a look at an example of the attack on the client side, which is the cross-site scripting example. Okay, cross-site scripting. So let me show you once again the cross-site scripting. So here we go. Okay, cross-site scripting. Okay, so it says please enter the search term that you want to look up. Okay, and just let's take a look at it. So if I say ABC, okay, and I say get this user, right, and notice it says, look, there was no result found related to ABC. Okay, so what I want you to notice is, notice how when I put ABC in there, that came back, right? So if I were to put in Terumi and get this user, Terumi is not going away, so Terumi stays there. And notice how the error message comes back with Terumi. So whatever I put in there, the error message has the need to tell me, look, you put in Terumi, so we didn't find Terumi. Okay? So that's basically, and this is important for cross-site scripting. So now, what I'm going to do is I'm going to put a script and put a little alert box that says, look, hacked. I hope this works. All right. So obviously that's not a name, and it is a piece of JavaScript. Okay. So I'll say get this user. Boom. Okay. And notice that I have a pop-up that says hacked. Okay. This is actually cross-site scripting. So notice what happens. Notice where at the bottom it says loading, right? It's loading. So if I say okay, what's going to happen is that the message comes back. Or in this case, it's you have successfully executed JavaScript command. Okay, but notice where it says sorry, but there was no result found related to whatever. Okay, so the JavaScript, what's happening here is after you're looking at the application, it receives your query, it goes look for it, right? And if it didn't find it, it is going to create an error message, has whatever you put into it. So I put in I put in a JavaScript in it, so the JavaScript message just gets repeated back. But once it gets repeated back, when the browser receives it, it's going to execute it. It's going to execute it, right? Because it's JavaScript, right? And that's exactly what just happened. And this is cross-site scripting. There are two different types of cross-site scripting. The type that you just saw now, this is called a reflective cross-site scripting, because I put it in myself, it went to the server, it came back from the server, and then it just blew up on my browser. That is, I got a pop-up message. Okay. There is something called a stored cross-site scripting, where somebody else, puts in, let's say something like a link, and you click, let's say on some kind of a Q&A site or something, and you click on that link because you were interested in listening, hearing the answer. Then boom, it just blows up in your browser because that link was actually a link to a script. Okay, that it comes into your browser and then it executes. Okay. So what's the big deal? Right? What is such a big deal about having this pop-up screen? What is the big deal? That's right. That's right. So I'm able to push this script and have it come back to me and execute it on my browser. Now, no one in the right mind is going to do that, to themselves, hopefully. Okay, so somebody else is going to force you to do that. Okay, so that's the trick with the cross-site scripting, of course. But what can JavaScript do though? So you can push it. So you're able to execute it. What can you do? What can you do? Can you do anything bad with this? That's right. The answer is yes. So with the cross-site scripting, JavaScript is now becoming pretty much close to a full-fledged programming language. It's not just like an inky-dink, scripts anymore. You could do a lot of things with it. Yeah, Terry. Right. You could do DOM. You can access DOM. You could do all kinds of things with cross-site scripting with the JavaScript itself. So. But remember, this is the part that is executing inside the browser. And of course, we do have JavaScript that executes in the server side, but cross-site scripting doesn't go there. But the cross-site scripting will blow up the server. So what can it do? Well, simply something like perhaps redirect you. So when it comes back, it's going to redirect your browser to another site. And the other site could be a malicious site that just by going there, you may be downloading a malware. See, that would be horrible. Or maybe it can create it actually can create the visual elements in your browser. So if this server, the vulnerability is on the server, by the way, and we'll talk about it, but if the server is a bank server, maybe the JavaScript can actually create a portal-looking thing that has a username and password that looks exactly like what the bank page looks like. And you put in the username and password, it's just collecting that credential. And when you say submit, it just scrolls it away someplace, and then redirect you to the actual site that has the actual username and password, so that you say, well, what happened? And then when you log in again, you are able to log in the second time. But the first time, they were just collecting your credentials. So there are a lot of things that could be done using cross-site scripting. Well, for someone to be able to kind of force this on you is an attack. Okay, so let's see then how does this thing work. Okay, you basically know how this thing works, but let me just go ahead and show you on the presentation. Okay, so let's say you have a server that is vulnerable to cross-site scripting. Okay, and you have a client who's going to be the victim. And let's do a reflective one first. So you have a hacker that sends something that says, hey, click here. Okay, but the click here is, let's say this is a, let's see if this is like test.com or something. Okay, so what it'll have is it'll have go to test.com, so test.com, and it's going to attach the script, whatever the bad script is. So when the user clicks on it, it goes there, boom. And maybe, I mean, the vulnerabilities shows up in various ways. But for the example that you just saw, maybe it is a, hey, please put in your username, and you know that is vulnerable to cross-site scripting. So this goes to that page, look up or something. Look up with the ID or something, okay? And it couldn't find anything, so it's going to send you back an error message and said, hey, we couldn't find that thing that you're looking for. And that thing, of course, is the script that we're talking about. So that script comes back along with the error message. And then it comes in and it blows up, right? Because the browser looks at the script and says, I have to execute it. Okay, so this is where it's reflective, so that somebody is kind of tricking you, social engineering you perhaps, into clicking that, and it's going to the vulnerable page that returns whatever's sent to it. Okay, you can have a stored version of this where someone actually puts in the cross-site scripting script right inside, so that when somebody clicks on it, same thing happens, it goes back, and then it's executed in the browser. Okay, so this is cross-site scripting. The vulnerability is on the server. I want to stress that. So now, but it blows up, right? Where it blows up is on the client side. Where the damage is done is on the client, not on the server. Okay, and stop this. How would you stop this? Right. What type of validation, Terry? Remove special characters? Yeah, right. On the input? Yep. Okay, remove brackets, right. Right. Get rid of those stuff, right? And so that would be one way of doing it. So that's going to be the let me put in here. It will be the input validation. So I've been using all these bright colors already, so here we go. You say as it comes back in, so it's right here. See right there? That will be the input validation. Okay? All right. So if you had a choice, well, if you had an option to put another validation somewhere, where would you put it? There's another place you can actually put the validation, right? Right, as it comes in and as it goes out. Yeah. Yep. So you could actually do something like an output validation. Right. So because if you're a programmer, you understand this. When somebody sends you something, in order for that value to go back as an error message, you have to consciously pick that up and stick it into a message and then send it back. Right? So there is a conscious process of receiving, processing, and then sending it back. Right? So you could put it in as you send it back, or as it, you could do it as it comes in, or both. You could do both. Okay? And if you have the same logic, there may be some value in doing both, because look, maybe not every time. It's not going to be reflective every time. So if it comes in through a different channel, right, like a stored cross-site scripting, then it may not go through the input validation that you've set up for it. Okay, but it will always go through the output, right? Because the output, that's where the attack is, right? That's where the attack is happening. And in fact, if you had a choice of either putting it into the input side or the output side, in this type of attack, you would put it on the output side. If you could only put it in one place, right? Because that's the last place that you can stop it. That's the last place you can stop this attack. But of course, you'll put it on the input as well. It's always layered security. So yes, you would do that. Okay, you would do that as well. All right. So I'm glad you mentioned that, because some customers will say, oh yeah, disable JavaScript on a browser. Right? I mean, long time ago, maybe that was okay, but nowadays, I know. You can't disable JavaScript on the browser, right? You stop everything from working. Yeah. So, but what's happening though is that with this cross-site scripting thing being so prevalent, some browsers are trying to detect if it's a cross-site scripting and try to stop it itself. But look, you can't always rely on the fact that people are going to be using those type of browsers. So yeah, I mean, let's fix where the problem is. It's right on the server. And what's the problem with the server? The problem with the server is it is just regurgitating back what it receives from the client back to the client. That's the problem. You're not supposed to just regurgitate. Okay? So there you go. But people do that, right? Because take for example, have you ever had a case where you go to a website and you want to register or something, and they give you a big old registration form that's going to take you at least like 5 minutes to fill out, right? And then you fill it out. There's so many fields, and you take time and say, God, I'm never going to do this again, and you submit, okay? And then it comes back with a little error message that says, oh, error, format on the phone number is wrong or something. Okay, and then all the stuff that you put in disappears. Boom, it's gone. It's like it comes back with a blank form. When that happens to me, I usually don't even do the second time around. I say, I'm not going to do this. It's wasting too much time for me. So if you make enough case about it and complain about it, maybe they'll fix it. So when they fix it, what do? Everything that you put in comes back. Right? It's the user experience thing. Everything you put in comes back, right? But when you do that, if you don't do the proper input validation or output validation or both, what comes back may be a cross-site scripting stuff. And so they just want to be nice, right? The programmers just want to be nice and see how that is a vulnerability on the server side. Okay, any questions? So these are the two main types of attacks that you get on the application side. And typical ways to stop it. Validation is always important. You saw the validation was important on the buffer overflow when we explained it, right? So it's about the exposure, application exposure, and don't consume stuff that you're going to do like you're going to hiccup on, right? So you have to make sure, right? We should put a nose on the application, right? Just like what we put in our mouth, we smell because we have a nose right above our mouth. So we try to stop it, don't eat junk. We should do that on the applications too. We should put a nose on there. We don't eat stuff. And if you don't eat half the stuff, like on the application, half of the stuff won't happen. A lot of these things won't happen because you're only accepting what you can process to be true and to do a proper error checking. It's all part of the game. Any questions? So, how many of you would be interested in using Security Shepherd? If you want access, I could create access for you. You download the VM? Yeah, you can run it. Yeah, this thing's in the cloud, so if you want it. But by the way, if you want it, it's on the other goodies. And go to the extra slides here. There is the Security Shepherd Lab. So just let me know. Just shoot me an email, and then I will just go ahead and allow you to go ahead and use that. Okay? So that is that for you. All right. So any questions? Any questions? Okay. So let me just quickly go to the slide and kind of pick and choose for the next 15 minutes or so what we can talk about that may be of essence. So basically, we go into the programming concepts. Okay, so when we're talking about source program, how it becomes a machine code into the microcode. By the way, there's lots and lots of background information about this stuff in your book. There's a lot of background information. Okay, so this is part of the background information, isn't it? Okay, so the source program. So when we do source code review, obviously that's what you're doing a review on. And there are different types of stuff like compilers, interpreters, bytecode. You will get something like this on the exam as well. You got to know the difference between the binary and the bytecode. The binary is when you compile it all the way through and you get something like a .exe. It is in the microcode. The interpreter is what you see on the interpreted language like JavaScript. So JavaScript, as it comes in a text form. And when it hits the browser has the interpreter for JavaScript. So it says, oh, it's a JavaScript. What do you want me to do next? And it will execute the commands as it comes in. So it's top-down process. That's the interpreter. Okay. Bytecode is what you see in Java. So Java is what's called a portable language. Portable. That is, you can port them over to multiple operating systems and platforms. And the way to do that is by using the magic of the Java virtual machines, right? So you'll have something like the, right, when you have, let's say when you have, Windows, you have Linux, you may have something else. As long as there is a Java virtual machine, you can run a program, a Java program that was written once. Because the Java virtual machine is what makes everything look the same. Okay? So that will be, and this piece right here is called a bytecode. It is not a complete binary executable. It is not. So the Java will require that you have this piece in order to run a Java application. So that's a bytecode. So it's like a halfway compiled code. Okay? And let me go back to the presentation. By the way, what I showed before was this: source program, compiler, assembler, machine language code, right, type of code. And then you have these interpreters and bytecodes. Type of software, there's something called open and closed softwares. Read up on that. People have opinions about, whether they're like open or closed. When it comes to security, though, you can't deny the fact that with open source code, people can go to the open source, just like what Terry just said. Just download the VM. You could just download the code, and you can analyze them. And I've done that before. And when I knew that the customer was using a particular open source software, like a portal software, and I would look at the, I would just go ahead and see if I can see any kind of flaw in the authentication scheme or authorization scheme, and see. It's easy, right? Because you have the code. Okay. So if you're willing to change the code from what you have on the open source, I think you'll be fine. And I really love open and sharewares. The closed source software, companies can't really be sitting on their laurels just because they're closed source. Just like what happened with Microsoft, right? It was closed for a while, and then until somebody stole the source code, and now it was open, open to the hackers, right? So it is security by obscurity. It works to some degree, but once it's revealed, it's gone. So you see, those are, I guess the pluses and minuses of these types of software. Crippleware is a type of software where all the features are inside the program, and when you buy it or when you download it, they're all in there, except you have levels. It says, okay, I have the basic level, I have the medium level, I have all the feature level, so that if you pay more with licenses, all these functions become unlocked. But all the features are already in there. You just have to unlock it using the license. So a lot of things happen. Windows are like that. You download Windows and they're just locked. Depending upon the license, it only opens certain capabilities. So I've seen people, out on the internet just sharing these keys that says, hey, here's a key that will open this thing up. Okay, so that is the upside and the downside of the crippleware. Okay, you do have to talk. It will go into a little bit about object-oriented design and programming because it is so popular, represented by Java. But Java isn't the only one, and in fact, Java is not even a truly object-oriented language. But I mean, that's something like Smalltalk is more of a pure object-oriented. But it doesn't matter when it comes to security. So please look through it. I'm not going to have too much time to talk about these objects and properties. So properties are like attributes, and methods are functions. And objects will have scope for these methods and properties, so that only things inside the object can see the internal methods and properties. And you also have other types where you open that to public. So public methods, public properties are available from other objects outside of the object in question. So the inheritance is a pretty interesting concept in object-oriented language, and I would dare say that is probably the hallmark of object-oriented language, is that they have inheritance. And this is just a simple example. So if you have an animal object, by the way, in object-oriented language, you have a template. It's called a class. So class is like a blueprint for an object. And when you instantiate an object, like put a name on it, have it run and move and things, then you have an object, right? So here, there are only 3 objects: the human object, the dog object, and the cat object. Everything else is just a class. Because notice, there's a big old question mark about an animal. You can't instantiate an animal object per se. You have to instantiate an example of the instance of that object. So with a pet too, you have the dotted line for the head and dotted line for the tail, because depending upon a dog or a cat, that differs. Okay, but what is interesting is the inheritance. So for the animal object, everything that is on animal inherits a brain. So brain equals true. Okay, so even though on the human you don't have a brain in there, well, actually you do have a brain, but you don't. It's not written there. Only thing that's written there is legs. Well, the brain is assumed to be true because it inherits it from the parent. Okay, and the pet also inherits the brain. Okay, but now, and the legs too. But now you could put the specifics. As a human has leg equals 2, and the pet has leg equals to 4, but and the fleas. Right now you're adding something here. Okay, so the pet class is now the parent class for the dog and the cat, right? So now you don't have to mention about the legs. They will have the legs and they'll have the brains, but the fleas, now that's a different story, right? So you can set them to fleas equals 8, flea equals 4, what have you. Okay, so that is inheritance. You can actually cut inheritance. So let's say a dog says, look, I don't want a brain. So you could just go ahead and cut inheritance so you don't get things that are from the parent. Okay, you can do that. Polymorphism is where, this is pretty interesting as well, is normally if you're not doing a object-oriented language, if you're just using regular language like hierarchical language like C, you cannot repeat a same function name. So in this case, the function is something called make sound. So you can do what's called the overload. So you can have make sound. There are two functions named make sound. They're the same. Except what's different is the argument that are passed to it. So the first one, you say dog.make sound, nothing in the parentheses. The dog object is supposed to say woof, right? And if you do a dog.make sound and Boolean, so it's either true or false. If you say true, which means injured, is true, and it's going to go whimper, okay? And what's more interesting is that the make sound can also exist in the cat. So if you say make sound with a cat, it's going to go meow. And if you do make sound Boolean injured, it may go or something. I don't know, whatever cats do when they're hurt. Okay. And what's interesting about that is you can actually load. You can try to make a decision as to what is this animal. When you're running at the runtime, there is a dynamic about you can load either dog or cat, and the program may not know which one that gets loaded because of the program. You can just test it. Right? You could just go, whatever, whatever it is, dog or cat, I don't know, but you could say pet dot make sound. If it says wolf, it's a dog, right? Okay. So this is called a polymorphism. So there's a complexity involved in there. So when you think about security, right? So if you have anything that's vulnerable that's passed down, all the kids, right? All the objects that are instantiated is going to have that vulnerability because it's inherited. Okay. There it is. There's a base class that is the template, and then you have the object, which once you put a name on it, instantiate it, you got an object. Okay. So there it is, the object with the public methods, private data, private methods. This is data hiding. Okay, data hiding is also called encapsulation. That's the word that is used in the object-oriented language. So you have the interaction, the interface, and you're protecting the object, the orange part, because you don't give direct access to the outside world, right? Very much a data hiding concept. The orbs, okay? And no, they're not the orbs that you see on, like, spirits, right? So object request broker. Here is this is primarily used for object reuse or the code reuse. Code reuse is to have a piece of code that other people can use, so you make it available to other people. In that case, if you had an application and you had a great function that you want to share with people, you don't want to just keep it inside, right? You don't want to just compile it inside your program, but keep it on the outside. Something like a DLL, dynamic linked libraries that you find in Windows, right? Those are shared, right? Other applications can call them. But how do they find them? Well, so when you see the client, so you see on the left-hand side, the box, that's an application. And on the server side, let's say you have a piece of function. Okay. So when you compile, when you create that application, you say, look, I want that function, but it's not, you're not going to include it. You're going to put something called a stub for a function. The stub fits with the skeleton. Okay. So it's going to go look for it. It's going to go look for the actual function, and the function doesn't have to run on the same computer. It could be running on a separate computer that's connected to the network. It just depends on the kind of lookup feature that you put in. So if you have COM, Component Object Model for Microsoft, you're looking for it within the same computer system itself. You're looking for that particular library that's being shared inside the computer. So that means it's running on the same operating system. If you do DCOM, Distributed COM, once again, Microsoft, so that you can now have a server that is running Windows Server, running, hosting that function, and the application could be running anywhere. By using DCOM, it's able to locate and run that function remotely. Okay. Corba is not MS specific, it's more of a standard. So Java will use Corba, Common Object Request Broker Architecture, which is what you see on the picture here. Okay. So now that you see the components are now separate, it doesn't have to be compiled into the application. So it's very much like, remember the monolithic kernel and the microkernel? So the monolithic kernel will have all these functions within it. But if you don't, right, you say, look, I only want to use them. I'll just go ahead and use the shared libraries. I'm just going to put a stub to them. Well, in that case, now the part of what you run in the program is residing on the outside. And when you have it on the outside, there are all kinds of security issues, right? It's like, how do you know that's the actual application that you're supposed to be running? Right? How do you know that nobody has changed it? How do you know it's there? Okay, because if it's something that's required in your application, and if when you go look for the library and it's not there, it's going to cause an error. Hopefully, it won't cause a fatal error if you handle the error handling properly. But the issue, right, with the programmers is that some programmers do not handle these error handling properly, so that your application may bomb if somebody were to delete it. And people will delete it maliciously. Okay. Okie dokie. Let me cover the database because I know that this is going to be in there, and that will be the last thing that we'll cover. Okay. The databases. Well, in fact, you know what? Let's go and cover the database. So type of database systems you do have is, object-oriented. I'm sorry, the relational database isn't the only database in the world, right? You have hierarchical databases. Example is B-tree. I've used them, hierarchical database, when I was working for a financial company. When the stock prices come down, they come in a hierarchical database format, and we don't take the time to say, well, shall we normalize this data, or shall we look up the keys and stuff? Because we don't have the time. We have to handle them very quickly. So we will take in some redundancies. But the relational database is all about getting rid of redundancies. Okay? So it's called a normal form, and when you design a relational database, you're supposed to get rid of all the excessive data or repetition of data. So SQL, structured query language, is what you talk to the relational databases to, right? Object-oriented databases, store the object. You don't have to transform the object. When you're running something in the object, let's say you have a dog object and a cat object, and you have to save them in the database, you don't want them to convert it to a relational database and then save them, because there's some inefficiency there. Just save the object, right? As long as you can search the object, you could do all the things you do with the database with the object, that's fine. And they're called object-oriented database. It used to be very slow. It probably is still compared to other databases because of the way they search through objects. But it's getting more tolerable because the CPUs are getting very fast. Okay. There is something called the NoSQL database, opposite to SQL database, and the example is the MongoDB. Okay. Directory databases, right? Active Directory is a database, something like an LDAP, right? So for the SQL injection, there is a exactly similar injection flaws for LDAP injection. Why not, right? LDAP is just a language to talk to the directory database in the background. SQL is what you're talking is a relational database. They're both databases, right? So you can do injection of LDAP. Relational database components. Please remember the terminologies. Database the table, the row is the same as record, is same as tuple. Column is the same as field, as attribute. Okay, chances are they'll talk about tuples. Okay, in the exam, key and primary key, which is unique, uniquely identifies a record, and you have something called a foreign key. Can somebody explain to me what a foreign key is? It's in there, but what does that mean? Matching primary key and the parent DB. What does that mean? What is a foreign key? Okay, so the foreign key is, let's say you have a user database, okay, and you have all the users, and the users are records, tuples, and they have to be unique. So there better not be two Terumi Laskowskis in there, right? There should be one. Okay, but let's say that you want to make it's an HR database with all the previous assignments for that person. Okay, well, if you've been in a long time, maybe you've been around a lot of departments, and if you're a brand new person, maybe you've just been in one. So in that case, you don't want to repeat and say Terumi IT, Terumi HR, Terumi admin. You don't want to do that. So what you probably do is create two tables. One is the department table, where you put all the departments that this person has been in, and the other one is called the user table. And in the user table, a person will have a primary key, which is unique to that person. And on the secondary table, where you have the departments, let's say Terumi has a key that is 001. Okay? And in the department key, if you want to say Terumi's been in 5 departments, you'll probably have 5 records, and each one of them will say 001 HR, 001 IT, 001 whatever. You see? And that key that is repeating on the second side, second table, that is the foreign key. Okay? So what they're saying is that if you have foreign key, there better be a primary key that matches that foreign key. That's basically what they're saying. And this concept is pretty important in integrity of the database. So in relational databases, integrity, right? Integrity of the database is pretty important. There's something called a referential integrity. That means every foreign key matches a primary key somewhere, right? So there better not be 001 IT without having 001 Terumi. So if I go away, if let's say I leave the company, they delete my record, there's no 001, they better get rid of all the other ones, where it represents what department I was in, right? Because you'll have what's called orphan records, right? Orphan records. You have child records without the parent. That is a violation of referential integrity. Okay? Semantic integrity. So semantic integrity means attribute consistent with the data type. So let's say my phone numbers, okay? And somebody sticks in ABCs in there. It's not the consistent data type. So you have to say, nope, can't accept that because that field only accepts numbers. Entity integrity. Entity integrity is that each tuple has a unique primary key, right? Each record needs to be unique. So Terumi Laskowski better have a 001 in there to make it unique. Okay? Not null. And the ACID test is very important in relational database. Okay. So the ACID stands for atomicity. So atomicity means atoms. Before we knew that atoms can actually be broken down into smaller pieces, right, like neutrinos and stuff. But atom usually means you can't break it down any further. So it's all or nothing. So let's say you go to a bank site. You log in. You want to transfer money. So you say transfer from where, from to where, okay? And the amount. And you say transfer. And it takes the money out of your account and puts it into the destination account, and then it comes back and confirms it. Let's say that's the process, maybe like a 3-step process, okay? Let's say you pick the company, you pick where you want to send to, you specify where you want to take the money from, and then you say submit, okay? And it takes the money out, and then the system crashes. When the system comes back up, what it's supposed to do is, looks like something wrong happened. I'm going to roll it back, right? Roll it back to as if we didn't do this thing at all. So the money goes back into your account, and there's no problems. If the money disappears, okay, and it does not show up on your destination bank, you have a major problem, don't you? Okay, so that's what the atomicity means. It's all or nothing. Either the whole thing completes or nothing completes, and you roll it back. The consistency is you have to move from one valid state to another valid state. So if you're changing information, okay, you cannot be in halfway done state, right? So this is related to the first one. It says, okay, so Terumi's bank account has been debited, so it's minus now, but we haven't been able to, add the number to the other bank. Well, if that's the case, don't end it there. It's not in valid state, so go back. Okay, so it has to be one valid state to another valid state. If you have something running concurrently in a database, make sure they are isolated, right? So that one process does not affect the other process. And if there are concurrent transactions, right, or serial transaction, make sure that if a serial transaction, make sure step 1 happens before step 2, right? That's what causes the race condition. Okay, so we have to be careful. Durability. Once committed, stays that way. Okay, so what that means is that, look, Terumi's account has been debited and the other one has been credited. Commit, right? Now it doesn't go back. It's done and over with. Okay, it's commit. So that's the acid test. Okay, chances are you're going to get something like this. Okay. And there are other relational database concepts. I'm just going to pick the one. Let me see. Normalization is how this is on the relational database. How you get rid of, design the database where you don't have redundancies. Okay, there's something called I think it's 5 normal form of Dr. Date. Dr. Date is the one that came up with this. Oh, 6 normal forms. Sorry. You don't need to know all the forms, but just need to know that these are how you design the database so that you have the least redundancies of data. Okay, database views. Database views are where, let's say you have, it's a major security issue, by the way, database views. Database view is where you have a table. Okay, let's say something like Salesforce.com. Salesforce.com maintains sales records. Okay, and let's say the field is company, and all the other fields are pretty important fields, and you have company A, company B, company C. So when company A logs in, the reason why the company A only sees company A information is because they're creating what's called a view of this table and showing to this person. When somebody from B comes up, they're only seeing this thing right here. That's it. Okay? But what if you have a hacker who does an SQL injection where it says company name is true? The person gets the whole thing. Notice that? Right? So this is because it's a logical concept. It's not a physically separated tables, right? So you could possibly have this problem with views. And in order to avoid this type of problem, you can do something called a poly-instantiation. So here it is. So you have something called a poly-instantiation. Poly-instantiation is, if you recall, let's say you have an HR database, okay? And on the HR database, you have the person's name, phone number, and social security number, okay? The HR person can see it all, right? But let's say this database is used for creating a company phone book. So regular users get a view of that table, only the username and the name and the phone number. But there is a chance that somebody can attack it and get the social security number, which is a major violation of privacy. Okay, so then security person makes a command decision and says, look, I'm going to break this down into 2 tables. One is for the HR, the other one is for everybody else. The one for HR contains all the fields: the name, the phone number, social security number. But for the users, for the phone book, it's only going to have the name and the phone number. There you go. So even if somebody were to attack the second table, they're not going to get the Social Security number because it's not there. However, you are creating a problem here. If you have someone who is a stickler for normalization, right, they'll say, what? You can't repeat the data, right? Because what they see is that you have to synchronize. Every time somebody changes the phone number, you have to synchronize, and you have to make sure they're both updated. So it's a pretty much of a headache. But, you know, what isn't in security, right? So do you pick security, or do you pick, you know, Dr. Dates with his normalization? All right. So with the commit, rollback, and save point, we did talk about it. So save point, actually save point is when you start a transaction. Remember the atomicity? To make it atomic, you have to say, here is where I start, and if something goes wrong going forward, you come back to the save point. So you roll back to the save point. Okay? So then if something doesn't complete, you roll it back. And commit is something does complete, you commit it. Right? Journaling is, does anybody know journaling? What journaling is all about? No? You don't know? Okay, so remember the RPO, the recovery point objective, okay? And let's say you're backing up your database once a day, right? And then you say, well, the data goes, you know, data is destroyed, we lose a whole day of, you know, updates. Well, if you have a journal and the last update, you can actually recreate the whole thing, the part that you lost, because journal is it's a logging of all the SQL commands that you have executed in that day. So if you have the backup database, if you just replay everything that's in the journal, you should be able to get the same effect. You should be able to end up in the same state of the database because they're all the activities that you did as represented by SQL statements. And you want to make sure you have a remote journaling so that this journal is saved someplace else so it doesn't go away with the database. Replication, of course, is a copy of the database. It doesn't have to be real time. It's whenever, you know, two locations connect with network that then the replication happens. So it doesn't have to be real time. Shadowing is more real time though, right? You have a shadow database so that you have the primary database and everything that is saved to the primary database is saved to the shadow database. Okay. Hey guys, so that's about all I have for you. I mean, there are additional things, but I think these are it's the thing that we've already covered already. And what I'm going to do right now before you leave, okay, is give me 2 minutes to save save the I'm going to export. I'm going to save my whiteboard for those of you that's interested. So I'm going to save it. Oh, by the way, if you could do the I would really appreciate it. You should have received from QuickStart the ID to log into your portal in QuickStart. And if you were to log in now, you would have an option for a class evaluation. So I'm just going to export right now. Hang on. As PDF. Okay, export. And it goes in as cissp 519. Yeah. They save. Okay. And it is saving right now. There are 38 pages. Any questions while we're waiting for the exporting to happen? Any comments or questions? No? You guys still there? Terry, you're there. Okay. Huh. Yeah, I will. Hang on. Let me go ahead and okay. So it is, there you go. Is that what you need, Terry? You have a link to that. I gave you the link. Do you have one or don't you not have one? Oh, really, Raymond? Okay, yeah, sorry about that. That's fine. Oh, okay. So, okay, hang on. So let me just go ahead and get that to you. So let me see here. Let me do the share. And here's the URL for that. Okay. And all right, so it's been all right, so now I'm going to do is cissp and just search the cissp here. 519 PDF. Oh, there we go. I have the PDF. And let me go ahead and save that onto the so hang on here. Let me just go ahead and upload. So 519 PDF. And upload. How long would it be available? What do you mean, the slides? It's available until I'm doing the classes. So it's available for a long time. Yeah, take the exam within a year and you shouldn't worry about it, right? Yeah, it'll be available at least for a year. Properties, so are you talking about the slides or are you talking about the files? Slides, yeah. It'll be available for at least a year. Open. I hope you're going to take it within a year, because if you wait too long, they may update it. All right, so here is the PDF version of my whiteboard, and of course it probably will look very cryptic unless you took the course. So there you go. There it is. Hey, thank you very much for being such a great audience and giving me some. I've learned a lot. So good luck to you on the exam. Yeah, thank you very much. And you have my email. It's on my slides. So if if you pass, let me know. If you don't, let me know too. That's fine. Okay. Please have a nice Friday. Mahalo, Terry. Yeah, come on back and have your meet, John. Yeah, hey, thanks, Jan. Thanks a lot, Raymond. Thank you very much. Thank you very much. Good luck to you on the exam. Christopher. Thanks. Thank you.